Hi everybody. Here's our next lesson in math. We're starting up section 6.5 today, solving complex equations. So this section actually is very similar to section 6.4, where you were using the distributive property to multiply within the brackets and expand things out, except now we're given a value for the total equation, and so we can use that to actually solve for x now. So this is going to be kind of like a big review almost of what we've done already in this unit. Here's the handout that I'm going to upload today on the lesson. So you can follow along with your copy of the handout with this YouTube video, and then that way you can kind of fill in the blanks as you go. So the textbook for this section starts on page 344. Again, remember to look at the bottom of the page in the textbook, not on the bar of the online version, but look on the actual page. So we're just doing a little bit of a warm up here, so feel free to pause the video right now if you want to mark yourself on some quick multiplication and division with integers. Don't forget the sign rule. If you're multiplying two of the same sign, it'll be a positive answer. If you're multiplying two of a different sign, it'll be a negative answer. So feel free to pause. Okay, so now that we're kind of warmed up, let's take a look at an example here. So this question here says the dimensions of a room are shown in the diagram. And we can see that we need to find the area of the room. So area is always equal to base times height. And hopefully you remember that with the hundreds grids as well from our last unit. In order to figure out that there's 100 squares, we'd multiply 10 squares across by 10 squares down. So this is the same idea, right? Except we know that this side is 2.4 meters and we don't know one of the values on this side. It's x plus 1.7 meters. So in order to figure that out though, we know that we still need to multiply these two values together. So you can write that as 2.4 times, and then in brackets, x plus 1.7. Or again, if we're going to simplify it a bit, we can just take the multiplication sign out. And this looks exactly like 6.4 now. So if new flooring for the room was purchased for $12.49 per meter squared, what is the cost of the new floors? Well, we can kind of expand this here and get it ready for problem solving. So we can use that distributive property to multiply within the brackets for both. And so this will end up being 2.4 times x plus 2.4 times 1.7. So we can rewrite that as 2.4x plus, if we multiply these together, we get 4.08. Now, we can't actually calculate the cost of the new floors without knowing one of two things. So if we knew what x was, we could calculate what the total meters were, total meters squared, and we could figure out with this price value how much those new floors would cost. On the opposite side of it, we could also calculate it if they didn't tell us how much per meter squared, but if they told us how much was spent in total. So if they said that they spent $450 on new floors, then we could go equals $450, and then we could solve for x and see how many meters squared were actually present. So because we don't have enough information, we can't actually solve that. Let's go to the next page. So recall that solving equations requires you to determine the value of the variable that makes the equation true. So solve for x. Just like with the order of operations, it is important to complete multi-step equations in the correct order to ensure that your solution works. So you can solve equations using this order, bliss. So B, and this is again similar to order of operations. So first off, we're going to expand any brackets. Then L, we're going to combine any like terms. And this doesn't really apply much to Math 8, but we might want to, complete multiplication in brackets and just kind of simplify things as best we can before we start solving for x. Then I, isolate the variable on one side of the equation and the number term on the other. So always trying to get x on one side by itself. And then S, solve for the value of the variable. So here's a couple more examples. I'll go through A with you and maybe C, and then you can use this to mark yourself as well. So if we have 3 and then x plus 5 equals 36, we can actually solve for x. So first off, we have to use the distributive property. So we're going to multiply to both values in the brackets and expand out. So this ends up being 3x plus 15 is equal to 36. And then we would solve this like any other equation where we want to get x by itself. So if we have plus 15, we're going to do the opposite and we're going to subtract 15 to both sides. So these cancel out. 36 minus 15 is 21. And we carry this one down, so we're left with 3x equals 21. And then to get the x all by itself, right now it's being multiplied, so we're going to divide it to both sides. These cancel out. 21 divided by 3 is 7. And you can plug this number back in. You can verify and check, right? You can plug it back in here to double check that it equals to 36. Let's look at C here as well. So because now we have a negative sign. So negative 5y plus 2 equals 25. So again, multiplying in with the distributive property, we have negative 5y, and then negative 5 times positive 2 is negative 10. So we can just say minus 10 is equal to 25. So to get the y by itself, we're going to get rid of this negative 10. So we're going to add 10 to both sides. We carry this down. We're left with negative 5y equals 35. And then to get y all by itself, we're going to divide negative 5 to both sides. So these cancel out. 35 divided by negative 5 is 7. Oh, sorry, actually this is negative 7 if this is a positive. All right, here's another problem. Mr. Smith is landscaping his yard. He's buying plants that cost $12 each. Mr. Smith needs 11 plants to shade his patio on 2 adjacent sides, but Mr. Smith wants to buy more plants for the other end of his yard. If he has $336, what is the maximum amount of plants he can purchase? So if we wrote this out as an equation, we know that each plant costs $12. So that one's going to come outside the brackets because we're going to multiply 12 by whatever he can afford or however many plants he's going to buy. So we know that he needs 11 for sure. So 11 plus x is our unknown, right? We don't know how many more he can buy. And we know that he spends $336. Okay, so here's our equation, and now we can actually solve. So distributive property, right? Multiply it in the brackets. So 12 times 11 plus 12x is equal to 336. 12 times 11 is 132 plus 12x. So to get rid of this, we subtract it to both sides, and we're left with 12x equals 204. Divide 12 to both sides to get 17. So we can actually buy 17 extra plants. All right, and last page is just a couple of examples. Feel free to pause this YouTube video and kind of take a look at the work step by step. Again, it's going to take you through using that distributive property and then just solving for x. And at the bottom is also your textbook questions for today. I'll be posting a key on this tomorrow. I'm also going to post up the YouTube clip from last week on the distributive property. I don't think a lot of people watched it, and it's a really good one from a new website called Mathantics. Even if you just watch half of it and kind of get the idea, it does a great job of showing you how to use this distributive property in order to expand your equation. Okay, so good luck with these questions, and we'll see you soon.